All right, let's get started. To our Twitch viewers out there, I want to apologize for not having a stream for the past couple of days. Work has got busy, and Saturday I just felt a little burned out, so I figured I'll just, a little under the weather, so I figured I'll just take Saturday away from streaming and working on any of the project stuff, just to kind of refresh myself and, kind of step back and kind of reset and center. For our YouTube viewers, thanks for hanging with us and checking out the videos and following along. Same kind of applies with the YouTube. Uploading videos is pretty much limited to how much, when I do the video stream. So if I don't do a video stream, I tend to not upload because usually I'm just too tired from work, too busy to work on doing anything of that sort. So I appreciate you hanging out with us and staying with the video series so far. Definitely like and subscribe and hit that bell notification to be informed of new videos. We really appreciate it. So in the last video, we started working on the ancillary project, the fan tester, the multi-fan tester. It was something that wanted to do anyway, kind of take a little bit of a break from the main project because we're waiting on PCBs to come in, kind of help kind of refresh and do some more design work for another project, another component. This is something that we need for it anyway to test the fans, and it'll be able to do other things, test other fans for us. So, it's kind of a win-win project. So I'm not terribly worried about it as far as any impact on our project so far. We were going to do it eventually, kind of like the resistor box. We just had to do it. I just figured now would be a good opportunity to kind of sneak a little bit of a break away and work on this, like I said, to kind of center, reset, and try to resist any kind of burnout from working on this project, because there's still a long way to go. There's a lot to do with this project still, with the stepper controller. So once we get the version 2 board built, we still need to incorporate all the tests, finish the testing process. That way we can get it tested and finish up that test fixture and start basically just testing how it performs under continuous use. But we'll get there. One step at a time. We'll get there. So again, we're back to working on the fan tester. I started doing some more preliminary work. So let's go back here for the other connector, which is the Molex connector for the 3 and 4 pin fans. So I started kind of creating the files in KiCad just to kind of save time, because we've been doing a lot of lather, rinse, and repeat when it comes to part entry. And I don't want to bog down the channel and the videos with just doing part entry. But since we're here, let's go and finish getting this guy added. So I've already got the footprint. I've already got all that stuff set up. Just need to go in and fill out the rest of this. Maybe a connector. Don't need that footprint. So it's going to be under connectors. All right, here we go. Got that. The description. Okay, connector. Header. For circuit. Vertical. Hole. Through hole. Friction lock. All right, let's see here. 2.54 Bitch. All right. Okay. So we got that. Okay. So this is a Molex part. Yes, sir. Let's get this a little bit here. Manufacturer one. Molex. Part number. Yeah. Trying to get this all done so we can get back to doing our design work. We have one more connector we want to find. All right, so let's get over to here. Mauser's part number is don't need all that junk. And low volume 0.42, high volume. All right. So, as usual fashion, I'm gonna go get this added to Odo real quick, because that's the last thing we need to do is to not go in here. Ew. 4705 33123. Okay, put it here. Boom, boom. Category, it's a connector. Description. Purchase it from Mauser. Their product code. 1.0 per single unit. All right, so we got that in there. All right, so we're okay with that. Got the symbol, we got the footprint. So we got the symbol, the footprint. Now, before we get too far ahead of ourselves, let's go to Mauser and see if we can find the. So we want a connector, basically a terminal block. We don't really need a pluggable. Basically, a fixed terminal block is basically what we're looking for. We need 4 positions. Pitch, I don't really care about right now. We need to see here. We're looking for a PCB mount because we want to build up. We need to solder it. All right. Let's see what we got. A screw would be fine, but it'd be nice to have something that, like a spring-loaded block like this. Look, you just push those guys down. Wait a minute here. Don't want something that's. See, the nice thing about that, they're right up here on top, like a 45-degree entry. Only 88 cents, too. Let's see what you are here. All right. Okay. Well, basically, you could use like a Let's see here. Wow. Been 20 AWG. Let's see what else we got here. Same sky. Screwless. White button. Oh, let's kind of check these guys out here. Gray, but I don't really care. All right. What's the wires? Okay. All the way down to 26 AWG. Screwless. 4 gray, white button. All right. Okay. That's looking tasty. Let's see here. Always decisions. So what are the count at? Screwless. All right. Let's go back to here. Screwless. Only 4? No. What do they care this? Push in. Let's go to push in. There we go. I mean, I do like that. This is not too bad looking. So these guys have levers. Huh. So the push-in, spring-loaded. So these are kind of neat, but I'm afraid that repetitive use could break those. I'm afraid repetitive use can break those. So I think we're going to maybe look at these guys because these Infinix contacts seems to be more reliable. 20 AWG, that's a pretty small wire. These are, let's see. Let's see if we can see how many from same sky. 21. Let's keep looking real quick. And again, dollar versus how much? Yeah, it's just that the Phoenix contact is cheaper. But let's see here what wire gauge you support. Wait, is this? Okay, it's 4 position down to 24 gauge. Okay. 4 poles. We don't need heavy pitch because you're just going to be, okay, pushing those buttons down. Okay. Okay, that would work because I don't anticipate, yeah, but the price tag, let's see, 63 cents for 10. See, you start getting the better price breaks in quantity. Single units. So here's where we run into that. Okay. So here we go. Single units, $1, and this is 88 cents. But like our now unit quantity, 72 cents at 10, and our 10. So that's what we're going to be looking at here. So what about, okay, 54 cents. Let's just say that. Yeah. So at quantity, we're going to get some slightly better prices on this guy. So that's what we're going to go with. So let's get the in gray. It's fine by me. Okay. It's simple. I don't really mind. Perfect. So let's go to the downloads folder. And honestly, the same sky stuff's actually been pretty good. I've never been disappointed with any of it. All right, so let's go to the footprint. Boop. All right. Okay. So we did that. Go and all right. We have part number, file, import footprint. Please have a KiCad version. Yes, you do. Oh. All right, we're going to save it as, oh, that's fine. Connector, terminal block. Got connectors. All right. Yep, see you. All right. Save it. Now let's go to File, Properties. Going to embed. All right. 3D models. We're going to trash that. Thing. Save it. Then we're going to check. Did it? Didn't save it. Okay. There we go. Boop. All right. So let's get you. Nope. There we go. Bet you now. Thanks. Five. All right. Oh, I always do that. File, properties. Some things you have to hit enter on before they'll. Now we need to go back. Nope. Again, these are just for like just for reference for when we kind of want to just see what the board's going to look like. Okay, okay. Okay, yeah. All right. We're going to save it. Perfect. Now we're going to go back to the schematic editor or symbol editor. Okay. Right, we're going to do symbol. Okay, terminal block. Well, it's kind of funny. All right. 4-pin. Move you out of my way. So let's get the pins in here. 1, 1. 2, 2. All right. Okay. All right, we got that. Let's go. Box drawn around this. Right. All right. All right. There we go. We got that. Now let's go ahead and bow. All right. Footprint. Let's get you. There you are. Boom. Let's see here. Block. Push in 45 degree. Push in 45 degree for circuit. Let's look at here. Volt. Wow, 5 amps. That's pretty impressive. 18 to 24 AWG. Should be more than sufficient. 3.5 millimeter pitch. Throw hole. All right. Do we have the temperatures? Oddly enough, no. Was. Okay. Y'all, let's add our other things. Okay. Oh, why keep changing that now? All right. Number. Fix that. Bump. All right. So it is same sky. Oop. That. Measure. We're getting there. Low volume, 1.1, high volume. All right. 1008 must be their vendor pack quantity. Okay. Now you let's see here. Add to Odo real quick. Bump, bump, bump. Connect all. And this way it could be for our, that way we can test other fans that just have leads on them. Oh, all right, so we're at it there. We got that. We got the schematic. Do save it. Now let's go back over to the main connectors. So that is that guy. That is going to be the fan that we use on the stepper board, but I will set it up so the power supply can be selectable. Pardon me. The weather shifting around is just bleh, got me all messed up. So let's go and add the other two connectors. Blarp, 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 blarp. Let's go here. Connectors. Okay, that's the power connector that we just added. Okay, so that's that guy. Let's go ahead and add that. And then here we go. Now, there are a couple ways we can do this as far as the voltage selection. So we know we have 12, 5, and 3.3 volt, or we will once these schematics are done. So let's go ahead, add the 3 point. I already have a 3 volt, 5 volt, 12 volt. Okay. These guys. Let's go over to fan connection. All right. So one, we can use jumpers. Or like a selection switch, for the voltage for the fans. We can either use like a little rotary switch or a little PCB mounted multi-way switch, or just like I said, just jumpers. So this is where things kind of get a little. Jumpers would be the cheapest option. So if we want to, the quickest and dirtiest way of doing this would be to, actually no, because one of the things I want to add to this is an LCD screen. That's what this guy's for. My goodness, I'm just losing my train of thought today. The Wave Share 2.4 some inch OLED screen, just for that way you don't have to have a serial terminal tied to this thing, and it's just easier to set things up. So we're probably going to want to 3D print some plastics. So let's go and kind of poke around this idea a little bit. Let's explore this idea. Let's see what kind of switches they have here. Product. That's going to be electromechanical. Knobs and dial switches. So there's rotary switches, which would be kind of cool. And then slide switches. Rotary switch might be kind of cool. So realistically, we need 3 position. 12 volts, 5 volts, and 3.3 volts. Let's just kind of, number of decks. We'll figure all that out. Let's not worry about that right now. Current reading for a fan, we are not drawing that much fucking freaking current. All right, so okay, these guys might be too expensive for something like this. Okay. It was a dreaming fantasy to do something like this. I thought it'd be kind of cool. Well, I mean, we're getting a little cheaper. C&K. I mean, okay. I don't want to pay that much for a switch. Okay, so rotary switch would be cool, but for this project, let's not think about rotary switches. Look at slide switches. Don't need it to be illuminated. 3-pole. 3-pole. Three-pole double throw. Let's see. Might just. Ow. That's SMD. It's okay. Here we go. I mean, the switch. Needs to have 3 poles, so it needs to have 3 individual stop locations. 3 pole. It needs to be like on, or something like that. Let's see here. Well, let's take a look at this guy. On. Okay, 3 pole double throw, so we need 3 pole 3 throw. Let's get rid of that. 3 pole 3 throw, I think is what we're looking for. Let's see here. Ouch. 3 pole single throw. Let's see what that guy looks like. Huh. Yeah, that's not the kind of switches I'm looking for. Oh, well, wait a minute here. Non-stocked. Okay. You know, I think we're just going to have to use jumpers. I was trying to avoid using jumpers. What other kind of switches do we have? Control switches. No. Yeah, I was really hoping a rotary switch would work. Well, let's take another look. Let's go back here. Let's 3 pole. Okay. Oh, we don't need an SMT. Oh, wait a minute here. Let's get past these. Let's see if we can get. So, 750. No, thank you. No, thank you. 530. All right. 3 poles, 4 positions. I mean, if it was 4 positions, that's fine. I think it's probably like huge. I don't want to go broke. Yeah, jumpers might be the best way to go here. Not D shaft. Let's take a look at you. Wait a minute. $4 isn't too bad. And your PCB mount. What? We might not. Okay. Wait. Hey, no, I don't want to do that. That was kind of weird. I didn't think I could do that. I learned something new. What are you? Solder pin through a hole. Let's see here. Let's look at more through holes. There's 18 of them. Let's kind of figure it out. So that might not be a bad idea, because even if there's 4 positions, one can just be off. And we can always throw in LEDs to indicate voltage selected. That might actually be kind of cool. All right. Let's look at this. Okay. 4 position, 3 pole. Let's look at the data sheet. Let's see how this little guy's wired up here. Hopefully it shows me here. I need to. Oh, you're not helping me at all. All right, let's see which one this one is. That's R. This one 2. One D8N. 61 SR 2612F. Okay. Oh, I hate trying to read their coding. Let's see this. Oh, well, that would be cool. Not overcomplicate our lives. Let's just go with jumpers. So I can use switches. Double check the switches one more time. Because I've seen decent slide switches. Oh, this is annoying. Oh, there we go. On. Wait a minute here. Yeah, 660. Oh, see, I don't want like a. Well, wait a minute here. Ugh. I don't want like one of these old guys because that might be fragile. And I don't want to spend a ton of money on a switch. Oh, wait a minute here. You see a K. Oh, 81 cents. Okay. Illuminated. No model available, but let's try to understand this guy here. Nope, won't work. On. Let's see here. I don't think this guy will work. I can pull 3T. Wait a minute. Wait a minute. So is that saying that a 1, the number 1, is driving me nuts? SP3T. Double pull, double throw. On. Okay, pause 1, you're at 1 and 2. Pause 2, you're between 2 and 3. Pause 3, you're between 2 and 4. Okay, so pin number 2 would be your common. Ooh. Okay. All right, let's see. You have any? That might work. That's not a bad price either. 81 cents. Have to see if we can find a little switch, but I think it'd hold up a little bit better than that other one. All right, let's see here. 200 milliamps. Oh, that should be more than enough for a fan. For a PC fan, I think. I don't know though. 200 milliamps. That'd be more than enough for definitely for the little fan. But for that big PC fan, 200 milliamps? Oh, it might not be enough. Oh, Let's see. Oh, wait a minute here. I want to spend a fortune on a switch. Same guy. 46 cents. Check out this guy. He's got a long actuator too. Wait. Double. I don't know. 300 milliamps. Better. All right. You know, let's just not go this route. It's just not going to work the way I want it to. I think what we'll do is we'll use jumpers to connect, control the voltage. It'd be the simplest, the cheapest, most effective. So let's go over here to fan connections. Do I have 2-pin jumpers? Yes, I do. We're gonna need 1, 2, 3. Oh yeah, that's right. We already have them. One for each voltage level. All right. So we get the connectors for the fans. All right, USB 32 and the power supply. So I guess the best thing to start banging together are these power supplies. So this is going to be the 5-volt. So let's get in here. Okay. Got some nice big juicy. Let's get these big 1206 guys in here. I don't know. Let's see. 1210. Those will be on the other side. Let's get these guys on the. Let's just get one on the input because it's coming from a nice regulated supply. Well, we'll go 2 of them. Let's go 0.1 UF. And then the 2 big 22 UFOs. We can go 0805. I mean, let's go put these guys on there. Inductor 2.2 microhenry. All right, here we go. I think that's what we'll also do is we'll put some LEDs on for the power supplies. That way we can figure it out. Yeah, that's what we'll do. Okay. So let's get this guy wired in here. Yeah, I know I'm scattered all over the board today. It's just it's just one of them days. All right, so let's get you here. Ground connection now. Right. All right, drop you there. Boom. Bump. All right. Bump, bump, bump. Bump. Stop. It messes me up when you do that Altium. KiCad. All right, so we're 12 volts coming in here. Okay, we can kind of snug this up a little bit. A little neater. Okay. Okay, so this is all the boost circuit. It's coming off this guy right here. All right. Move this guy out of the way. I don't want to accidentally drag him into this mix. So boost goes to this guy. This guy goes to here. These guys cleaned up. Here. Still not used to it. I have to jump between KiCad and Altium and all that kind of makes things a little difficult sometimes. And the feedback goes after the inductor. All right. And now we got our 5 volts. All right, let's kind of put you up here. Box. Oop. Here. Hmm. Ooh. Is that actually an, oh, I actually did a 0. That's funny. Doing that when I can. Let's grab the dirt. Let's grab you. Pop. What's cool about this is we got to change out that one part. Right. Now, let's see here. Change symbol. I think 203. No, guess that's not how it's done. So, all right. Thought we could change it, but I guess we can't. 203. So 203, that's a 3v3. We're going to double check it. 3.3 volt. Okay. 5 volt. Okay. So now we have our 3.3 volt and our 5 volt power supplies laid out. Or PCB, or not PCB. I'm an idiot. Set up here. So let's go over to ESP32. We might throw some test points in. I'm not 100% sure what direction we want to go in yet, but we will consider that. All right. So I know we need, let's get these guys out of the way. Boop. Three volt. Ground symbol. Boop. I don't know why I like doing that, but I like doing it that way. Just copy and paste without accidentally grabbing the wrong symbol. I love when people advertise to me my own Twitch stream. Lovely. Okay. So we have that. So let's go and kind of drag this stuff over here because we need one of these little guys. Burp. Again, still mix that up here. Stop, KiCad. Stop. A little bit. There we go. Right. Now let's put this guy. Enable. All right, ESPN. Oh, yeah, this guy. Right. All right. Boom, 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 boom. This stuff cleaned up. Now what we might do is, prior to moving anything over to the PCB, is once we're done with the design, let's go through and tell it to basically reset all annotations and basically, that way you can kind of start them over in a better order. That way they all get clustered together a little bit better for the PC, for the layout and stuff. Sometimes it's easier to do that way. That way you can keep everything kind of organized together. There, there, come down here. Three. Burp. Enable. And then we'll get our buttons for the boot and reset up here. So, all right. We're also going to need a 10K. I almost forgot. Man, I don't know why we got so many 6.8K resistors. Must have accidentally grabbed them. Sometimes if you're not paying attention, it'll do that. So we need a 10K. 10K. It is on IO0. Where we get that. And let's give it a net label. It's going to go here. Let's just start there. Actually, we can drag that all the way over here. Go boot mode because the switch and the stuff, or the little push button. Okay. Oh, I don't know if I'm accidentally duplicating parts or what. That's just bizarre. Oh well. All right. Let's go here. Let's get this guy up. All these grounds. Tied together. Do everything we can. Okay. All right. Okay. Okay. Now we are going to need a vector. Connector header. Or we don't need that guy. We need a 4-pin. We don't need that. Okay, now I'm actually kind of confused because I know we have a 4. Oh no, we're using 6-pin. Okay, we need that. And then, do we have any TVS? Let's see here. Dual bidirectional pump. Okay, so TVS protection for the UART interface. So what we're going to do here, that's going to be for the UART to go to TXRX. Okay, here. It's going to be for that guy. So let's go ahead and get this guy. All right. Net label. TX. RX. Okay. Oop. Oh. Okay. For the sake of our schematic, to make it a little bit easier to read. So, nothing is connected to 6, 3, or 2. Pin 1's ground. Three is ground. And better double check the FTDI pinout because I need to make sure that we pinout. I got to make sure I get that right. All right. The correct pinout. All right. All right. Ground. Pin 4. All right. TX. All right. Pin. Be pin 5. And ESP. All right. Oh. So pin 5, so coming out of the FTDI cable, pin 5 is actually RX, but you reverse it, so it should go TX. And pin 4 is TX, so it becomes RX. So yeah, so you need to cross over your UARTs. So there we go. All right. That's good. Get that out of the way. All right, maybe I validated my pinout. Boom. Okay, now. So, I want to figure out. Okay. All right. Plus, we need to figure out. Oh. Okay. So here's what we're going to do here. 4. 16. Going by pins that I've used before that I know are correct. So it's going to be I see clock And I2C, yay. So that's going to be for the LCD screen. All right. Let's these guys out of the way. Let's go ahead and wire up the LCD screen. All right. All right, copy this. All right. Okay, so I'm going to wire this up in the way I wired up a couple other my other LCD screen for another project. And this is going to be I2C clock because I know it works and it's reliable. It's going to be off 2. 3 is data. Okay, number 4 is ground. No. Boom, 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 boom. All right. To here. To here. Never really had a problem with an LCD needing bypass caps, but it couldn't hurt. Couldn't hurt. Add a little bit of bulk capacitance for that. Okay, so this is for the LCD screen. Boop. Okay, now. All right, so let's get over here real quick. All right. What is this? Okay, so that is the fan. All right. Okay. So this is the PC fan connection. I'm gonna get these guys kind of tied up together real quick here. Before we end the video, just so something accomplished here. Okay, so I need a 1K resistor. I need a couple, I think. Let's tack. Only one's going to be connected at a time, so RC. All right. Oh, already have a 1K resistor. I am just confusing myself. And that will be 3.3 volts. Oh, that's kind of interesting. Okay. Fan tack. Oh. Be common between all of them. All right. So that's going to be your VCC. Get that guy. Fan, we're going to call it fan VCC. Because, well, typically the fans in PCs are 12 volts. Who's to say that we couldn't run across one that's 5 volts that has the same pin out? So, well, I mean, if you accidentally set it for 3 or 5 volts, it's not going to really run that effectively anyway. So that would be fan VCC. Get a port in here. It's going to be fan tack. And that is on. Okay, it's got to be an output. And tack. Just want to make sure. And then, why are these ports so big? They're huge. All right, let's get another. And then fan PWM. This can be an input. Let's draw you over here. Could space those further apart. That was my fault. I will. So this can be a shared signal. So we might do something different with it. So we don't have any duplicate. I mean, technically. To wire this one up. Because that is the computer fan. My note. Uh, 3 or 4 in PC. Typically 12 volt DC. All right. Yeah, those would be common signals, so we only need the one port. The other ones can just be net labels for the other fans. The fans VCC is basically going to become like a common off of these guys. Okay. I'll figure out how we're going to do it. Okay. And that's our fan, and then this will be the terminal block. All right. So we will end the video here. I appreciate you hanging out with us this afternoon. Again, I apologize for not streaming or dropping any videos recently. Again, work is picking up. I'm getting busier. So I don't know how long that will last. So I don't really anticipate being able to stream too often during the week because of the projects going on and how exhausted I usually am by the end of the day with everything that's got to get done. So thank you. I appreciate it. We appreciate it. You have a good rest of your afternoon, and hopefully we'll see you tomorrow, depending.